Trigonometric identity, tan square x divided by 1 plus tan square x equals to sine square x. So as we have discussed earlier, what we will do is we'll write tan as a ratio of sine over cos, right? So we know tan x equals to sine x over cos x. Another important thing which we see here is that, we really don't need cos x. So what we can do is multiply everything by cos x so that we get rid of cos x. So that is the kind of strategy which we are going to use to solve this identity or prove this identity. Okay, so let's start with the left side here. So on this side I'll just put some of the remarks if required, and let me start with the left side. So I have left side, which is tan square x over 1 plus tan square x. So I can write tan as sine over cos, right? So it becomes sine square x over cos square x divided by 1 plus sine square x over cos square x. Correct? So now we can take common denominator and then cancel out cos. But what we can do here is we can multiply numerator and denominator by cos square x. Think like this. So let's multiply both numerator and denominator by cos square x. So if you do that, so this cos square x gets cancelled and you get sine square x in the numerator, right? And in the denominator you get 1 time this cos square x cancels, you get 1 times 1 plus sine square x, correct? So you get cos square x. So cos square x times 1 is cos square x, plus here it will get cancelled, and so you get sine square x. Is that okay? Now you know cos square x plus sine square x is 1, so you get sine square x over 1, which is equals to sine square x. Is that okay? So what we did here was, it was 1 plus sine square x over cos square x, right? So we multiplied both by cos square x. So when you open the bracket, you multiply cos square x with this and also with this, right? So when you multiply cos square x with 1, you get cos square x, and when you multiply cos square x with sine square x divided by cos, they get cancelled out and you're left with sine square x. And as you know, in the identities, that sine square x plus cos square x is how much? 1, and that's what we replaced this with, right? And so we started with the left side and we got sine square x on the right side. So this identity has been proved. Okay, thank you.